Standard form is this ax squared plus bx plus c, and there's three different examples down here. The first one has an a, it has a b, and it has a c, right? You got your a being 3, your b being -5, and your c being... And you guys, don't be the typical kid who first sees these things and gets confused. In G, B's not missing. What's kind of understood to be there? A 0, right? In example 3, C's not missing. What could you write on your piece of paper? Could you write +0? You know, it's got all the pieces. But those are quadratics. What makes you a quadratic is that guy right there. That second power is what makes you what we call a quadratic. That's what makes you a quadratic. Here's our real world example where some of this stuff is actually used. It's not the best real world example, but it'll suit. So suppose TI collects the data shown in this table, which relates the number of calculators sold at the price P in dollars per calculator. Blah, blah. Since the price of a product determines the quantity that will be purchased, we treat the price as the independent variable. That's your X over here. And the relationship between the number X of calculators sold and the price P per calculator is approximated by this linear equation. So we're actually talking about a linear equation here in a section about quadratics. Now, TI wants to maximize their revenue. At what price should they sell a calculator? I'm pretty sure in this class we've talked about what revenue is. What is revenue? You have a lemonade stand. You charge a quarter for each lemonade. You sell 50 lemonades. How do you figure out your revenue? You have a lemonade stand. Okay, let's just use easy numbers. You sell every lemonade for $1. You sell 50 lemonades. What is your revenue? 50. How'd you do that? Okay, but in general terms. Price times quantity. That's what revenue is. Revenue is some X times some P, where X is the quantity. X times the price. P stands for price goods. Now, TI wants to maximize their revenue. We need to form the revenue functions, what we need to do. The revenue is this X. That guy right there. 21,000 minus 150 P's times what else? What else? What do I still need? P. What you did is you formed a function for revenue in terms of its price. That's all you did. Distribute in 21,000 P's minus 150 P squareds. We talked about stuff like that in section 3.6 maybe. Which y'all didn't like. The 3.6 was the modeling section. Nobody ever likes that stuff. Now that's not written in terms of X, but it's going to do the job. We can go back and figure out what X is. The question here was, at what price should they sell a calculator? Now, you have a quadratic in front of you, and they want to maximize their revenue. If you think about the graph of a quadratic, specifically focus on this piece right here. Does that one open up or down? Got that negative 150 P squared. Does it open up or down? Probably looks something like this. Little point right up there would be your maximum. That little point has a special name. What is it? We call that point. What do we call it? In a quadratic, no. It is a maximum. It is local. Actually, an absolute maximum. What do we call that thing, a vertex? This is at the vertex. There's a little formula that gives you the x-coordinate of a vertex for quadratic. Is he ready to call that guy? That's exactly what it is. 1/2 the quadratic formula. X-coordinate of the vertex is opposite b over twice a. Well, that's not shrinking the way I hoped it would shrink. At all. Oh well, I got some writing room. So why don't we apply that to our little guy down here and see what the price is. In this case, it wouldn't be X, it would be P. We're talking about revenue as a function of price. The price coordinate of the vertex is opposite B. Look at your formula, 21,000 P minus 150 P squared. Which one of these is B, 21,000 or the negative 150? 21,000, right? So negative 21,000 sitting over twice the negative 150. There's some math, kids. You got a negative over a negative, that's positive. Twice the 150 is 300. 21,000 divided by 300. 70. Well, this is a lie. Telling me that revenue is maximized when they sell a TI-84 for 70 bucks. Why are they 130 at Walmart? There's your maximum price. Okay, that's the optimum price. At least according to this model. How many were sold? How could you figure that out? Don't use the chart. I guess you could. This is an approximation. Came from this guy right here, 21,000 minus 150p. Plug back in. X equals 21,000 minus 150 70s. 10,500. It's 10,500 if my brain's working right this morning. Doesn't quite agree with the chart because it tells you in the very beginning that that was an approximation. But if you use approximation to figure that out, now you know that's a lie. Has anybody actually bought a TI recently? Go ask your parents what they cost them if they bought you one. They're not 70 bucks. They weren't 70 bucks when I was a kid. They were 120 then. All right, now I wanted to back this up with a graph. I really don't like showing graphs because kids think they don't need to memorize their formulas, but then they can't use the calculator either, so I guess it kind of washes itself out. But the equation we came up with was 21,000x minus 150x squared. If you zoom 6 that thing, you're not going to see anything. You should know you're not going to see anything. I didn't. Look at the units you're selling. Number of calculators X. If you just look at your chart, it goes up to what, 11,000? Price per calculator P, dollars. Our equation was actually written in price. But because we did a little bit of math by hand, we actually know some things. We know the maximum price is 70, and we know that X is 10,500. So it gives us some stuff to play with in the window. I'm going to change my Y max to 100. Oops, not 1,000. And I'm going to have to jump way out on X max. Way out. About 22,000. The reason I'm doing 22,000 comes from that guy right there, that 21,000. I'm hitting the graph button. And hopefully I'll see something, and I saw absolutely nothing. Why did I see nothing? Yep, I was. Maybe I went out too far on that thing. Oh, I've got my numbers backwards. P here. Look at its location. Is that X or Y? That's X. I've got my things backwards in my window. X max is 100 is fine. The Y max needs to be around 11,000, close to where that vertex is. I guess I could have guessed with the numbers and got there sooner or later. Still don't see anything. I really ought to be seeing something. X max 100. I don't know. I'm not going to mess with it. I don't want to waste 20 minutes on it. I don't know where it's at. I don't know why the calculator's not seeing it. Maybe a zoom fit might work. Might try that. Might play with the numbers. But anyways, did it by hand. I'm confident in it. Next up in your notes, graphing something by hand. There's a lot to this. There's a lot of things you should try to find. We're going to start off by finding the x-coordinate of the vertex. There's a little formula for that. How do you find the x-coordinate of the vertex? Just Aaron gave it to us. Here's the O2A. So you guys spend 20 seconds of your life and figure out where it is. Well, if you're still confused about the alphabet here, B is 8 and A is 2. Anybody get anything? -2? I'm pretty sure that's right. You have a -8 over twice the 2. That gives you the x value. How do you find the y value if you know the x value? One of those things some kids will miss. Anybody come up with anything? I see some nods. What'd you come up with? -3? Is that right? It'd be -16, -11. That's right. -3. That's a point you can plot. Back 2, ball 3. It's about right there. I wish I could remember how I taught y'all last year. That's a very special point. That is the vertex. What passes through the vertex is the line of symmetry. And it's at x equals -2. Those two are the same thing. Now, what's something else you might want to draw this parabola? A lot of things you can go after. No suggestions? I'm going to go after the y-intercept. How do you find a y-intercept? Well, 0. That's pretty easy. If you plug a 0 in for x, every place that you see an x, what are you left with? 5 is 5. Right there. Now you actually have enough to graph this one. We'll go to more detail here and find other things we can't find because not everything has a y-intercept. So I don't just want to do a y-intercept and be done with it. That is enough to graph. If you plot that y-intercept up there, it is 2 units from the line of symmetry. There must be a third point that is also 2 units from the line of symmetry. So there must be a third point over here, about right there, because that's the line of symmetry. That is enough to draw your parabola. It takes 3 points to draw a parabola. You have 3. Other things you might go after. X-intercepts. You might find an x-intercept. How do you find an x-intercept? Y equals 0. You'd have the equation 0 equals 2x squared plus 8x plus 5. Now, depending on how difficult this is, I may or may not do this. If I did it with quadratic formula, I probably would not do it. Unless it specifically tells you to do it. What if that factors? My gut says it doesn't. But because this is our first example, we'll do it. We'll hit it with quadratic formula. Wait, remember the quadratic formula? Right to me. Didn't say it, but it was right. We have -8 plus or minus square root of an 8 squared minus a 4 times a 2 times a 5, all sitting over twice a 2. Inside that radical, we got 64 minus 40, 44. No, 24. So that wasn't something that was going to factor. It's not even going to be something that's pretty. It's going to be a decimal. And you could approximate the decimal if you wanted to. About all I would do is I'd clean that radical up and be done with it. 24, is it 4 times 6? What's the root of that 4? 2? Maybe -8 plus or minus 2 root 6 over 4. And that could be cleaned up a little bit. You've got that -8 over 4, which is -2. 2 over 4 reduces to a half, so root 6 over 2. There's your other x-intercepts. Not anything I would worry about plotting if I was graphing by hand. And that's the gist of it. Those are things you can go after to graph. And like I said, this one was kind of nice. We actually could have been able to graph it just after the y-intercept. No, I didn't write it as a single fraction. And another acceptable answer would be -4 plus or minus root 6 all over 2. Is that what you wrote?
Yeah, that's what I was saying. I was just wondering.
I broke the fraction apart. What you only need is your 3 points from the get-go, and you had them. The only other thing that's in this section is when you start talking about domain and range. It was before Christmas, but you all took a mother function quiz. I didn't put domain and range on that one, did I? No, I didn't. I should have. I was trying to be nice. I'd actually deleted it off of it. What's the domain of that parabola? Does that parabola run forever left and forever right? What's its domain? That's negative infinity to positive infinity. All parabolas have that as domain. How about its range? -3 to infinity, I agree with that. Anything special about -3? Bracket. Because that is a point that exists. You can touch it. Heck, you drew it. That's it. I don't know if you guys did this your Algebra 1 year, but you were supposed to. All right, locating the vertex without graphing. Heck, we've already done this. We did this in example A. How do you find the x-coordinate of the vertex? -b over 2a. Nice simple formula. Now, I usually, when I'm doing this stuff by hand, I always label it like that. X subscript V. Of course, kids don't adopt the way I do things. I wish y'all would. If you just say X equals, like, you're really not saying specifically what it is. But if you put that little subscript V down there, you're telling yourself what you found. What's the V stand for? Vertex. That's why I do it. I don't feel like showing the work for that. What are you going to get? 3/4. All right, it did tell us to locate the vertex and axis symmetry. We haven't actually found the vertex. We found X. We also need Y. How do you get that Y value? Plug it in. I hate typing. There we go. So you plug that sucker in. I'd expect most of y'all would probably be using a calculator to do that. Isn't that 1/4? No. Go check me. What'd you come up with, Leah? You did not come up with 1/4 because I forgot to multiply by 2. 7/8. That'd be 9/16, 18/16 minus 9/4. Yeah, 7/8. So there's your vertex. Vertex is at 3/4 and 7/8. Now, it also asks for the axis of symmetry. We just go back and look at the previous example here. As soon as you found the x-coordinate of the vertex, after we plotted the whole vertex and drew in that line, didn't we have the line of symmetry? So if the x-coordinate of the vertex here is at 3/4, what's the line of symmetry? Yeah. Line of symmetry is x equals 3/4. This also comes from that negative b over 2a. Same thing. The other question here is, does it open up or down? Oh, not everybody knows that. So those of you that know this, how do you know it opens up? A is positive, right? There's an a in front of that x squared, and it's positive. That determines whether you open up or down. 4 of 9. The next one's a graphing problem. We're not doing it. We're not doing it. So we're jumping to vertex form. Now your task here is to graph y equals 2 times x minus 2 all squared minus 6 using the vertex form above, which I don't have in there. Anybody remember vertex form for a quadratic? But every form you learn in a math class uses the letters h and k. Vertex form for a quadratic is y equals a times x minus h. Quadratic, so what has to be done with that piece? Squared plus k. The vertex is at hk. If you guys have been using the forms that I've been asking you to on the project, this should make sense. Heck, that's how you're supposed to be writing those quadratics, isn't it? Some of you are not. It's just something I'm going to start documenting for. Use that form. You've been using vertex form. So, where's this thing's vertex? Here's the equation. Where's its vertex? -6. Where's the axis of symmetry at? 2. X equals 2. It is a line. So the right 2, all 6. Right there. There's your line of symmetry. I'm asking here for a couple little things. The y-intercept, because I can find it. How do you get that y-intercept? It might be. How'd you get it?
Oh, never mind.
How do you find a y-intercept?
0 for x.
0 for x. I don't think it's -4.
No, it's not. Okay.
That's enough to graph this thing. That thing is 2 units to the left of your line of symmetry, which means there is another point. So, all right. Domain and range are up. Domain is always negative positive. Always. It's parabola. What's that parabola's range? Sorry. Range, yeah. What's that parabola's range? -6 to infinity. Low value is -6. Does that -6 low value actually exist? Yeah. I've got a question on here about max and min value. I mean, we can answer it. It's y equals -6. It's a min. Only thing I'm too concerned about. Does it have a maximum value? Does it have a maximum value? It does not. The thing shoots off to infinity. You have no idea what its max is. It's an idea. And that's vertex form, which is what you guys have hopefully been doing for the last 3 months this year. Because it's been in your projects, kids. Yes, up next. Finding a quadratic function given its vertex and one other point. So your task is to determine the quadratic function whose vertex is at -2, 3, and whose y-intercept is at 1. Well, I gave you a vertex. It's telling you to plug into vertex form. And if you think back about your project the first 6 weeks, and even the second 6 weeks, actually you only had it the second and third 6 weeks, that was how you were taught to do these things in the first place. You already know how to do this. So we have y equals a times x minus h all squared plus a k. Do some replacement. I don't like to throw everything in on the first line. A lot of kids do, and they never seem to know what's going on. The first thing I do on line 1 is I replace h and k. I don't know what a is. What's h? What's h? Okay, minus -2, yep. Plus k, which is 3. Now on my second line, I would worry about what y and x are. Where do you get y and x? Y-intercept is 1. That gives you an ordered pair. The y-intercept is 1. What's the x value? That's where you get y and x, isn't it? Tells you that y is 1 and x is 0. So 1 equals a times 0 plus 2 squared plus a 3. Now be careful about how much this math that you do in your head, and make sure you don't kind of intermingle stuff you shouldn't. That a is attached to a 2 that's squared. Then you add 3. You don't say, oh, 2 squared is 4, add 3 and put a 7 there. 3's not married to a. You can do a little bit of math. What's your a value? -1/2 is correct. So your equation, which you've been doing for a while, hopefully, is that y equals -1/2 x plus 2 to the second power plus a 3. And that shouldn't be anything new to y'all. I'm pretty sure your bell's about to ring. Now you can get to talk about the word problem.
Run a dog?
No, I didn't run over, but there was one that was just legged on 89 miles.
I saw you missing at the gas station. I thought you were in gas station. Every single day I've seen that.
So coming back is any late homework you might have turned in. Probably a basics quiz and that 6 weeks test. He is never here.
I thought he was here, but a bunch of them.
He's never here. I can't remember what you made.
Really good.
There weren't many good grades on that. Yeah. You could have, all you had to do was copy down where I went over the twin, look at the examples, and do the same problem. Did you look at the video where I did worked out the twin? Okay, you had access to that while you were taking it.
That's not fair.
Everybody had access to it.
They know that, so they won't change.
It even said in the instruction set.
I can't read. This is math, not English.
That's retarded, son. Those tests were not what I expected them to be because you guys had at your disposal a twin with the same type of question right next to it. So I don't know what was up with those tests I gave. That's on you, kids, not me. You tell your parents that you had access to a twin while you're taking a test with the same question but different numbers. And you made a 40, or whatever you made on that thing. That's not me. I'm sorry you were in quarantine and can't read, Ty. But I'll give you this. You were only half the kids in quarantine did anything. You did that. That's better than some.
I thought it was everything. Well, no, I missed a couple days because they shut the program on me while I was doing it.
I'm not going to go over that quiz or any of that. Usually I do, but I'm not going to today. See, Sean? Oh, there is one thing I want to talk about. I posted on the classroom last night. Before I actually teaching. You guys, there'll be letters sent home too about this if you're flunking. Your parents will have information about this. Let me zoom in so we can actually see this. All right, on your Google Classroom, it's on the main stream, it's under Classworks, just under Stream, you'll see right there. Click the link below to join my Khan Academy class. Okay, so you click that link and you join up, and it is pure extra credit, and I can and I will look at the time it takes you to take through this thing. Y'all's biggest problem is multiple years of using and cheating. That is your problem. That's why you don't know anything. So I will look and see how long it's taking to do this stuff. But what you can do is you can do what's called the Algebra 2 mission. If you are failing 6 weeks, for every 15% of that mission you do, I'll replace that 6 weeks with a 75. Okay? If you're passing, every 1% completed is an extra point on any particular 6 weeks. Usually I just pick the lowest and work with that. And if you've done more, I move on to the next lowest and so forth. And just put the points where they help the most. So it talks about the Algebra 2 mission. So I'm going to log into Khan Academy. I'll log in on an old student account. I think I've still got it saved. Why didn't it? Well, why isn't that there? I had a student account saved on here. There he is. Trade.jet. Anybody remember Trey? He graduated about 5 years ago. He was one of those kids too who never did math on paper. He always made like 20s and everything. He was one of those kids. Sound familiar? Yeah, a lot of you are those kids. You really are. Couldn't do anything. His dad watched him like a hawk while he did this, and he did it. He spent about 4 months doing it to pass my class. And by the end of it, he was actually one of my better kids because he started picking up a pencil and paper. And he started actually doing the math, and he actually got pretty good at it. I mean, he didn't take me for pre-calc, but he took bridge math, and he was the first one done in that. That was back when bridge math was on a computer. We tried that 1 year. He only had to complete so many modules, and he was the first one done in there. He was done by Christmas with his senior math course. He got really good at the subject. Anyways, one of the first things you'll see here is where they talk about personalizing. You know, pick 11th grade, kids, even if you're in 10th. I'm going to pick 11th grade. And what class are you in? So I'm going to pick Algebra 2. So you log in, you go through that personalization thing, and I want you to do the mission here. They've got some suggestions here on where to start, but I'm going to go up to search and I'm going to type in Algebra 2 mission. Unless they've removed it. I haven't used this in 2 years. He's already done most of this thing. I should have used a different account. But all you'll do is you'll kind of click on Get Started and it'll launch you through the mission. He's got to do a mastery challenge. But it will launch you through on all the things in Algebra 2 that you need to do. And you're doing the Algebra 2 mission. If you can't find it, you just type in a search bar, Algebra 2 mission, and it'll bring it up. Anyways, back to what it says there. There's a due date on this. It's the easiest due date to ever remember. Historically, your EOC is given around the 20th of April. So the due date is 4/20. Okay? Every single one of you can remember when this thing's due. When's it due? 4/20. Because you're teenagers. I was a teenager. 90% of all teenagers are. Yet.
Yeah. Awesome, give me something to
Is that why you call them happy? All right. On to Algebra 2. I'll keep that set down. I forgot to stop recording.
Give me a small size. I think you probably split it. Try to get a bigger